Hello again, everybody. CJ here, your local friendly technology addict, and this is a mini episode of the Tech Addict's Attic. That's right, I'm going to try to keep this one short. We'll see how well I do. So, in this circuit in front of you, I have my microphone amplifier that I was building. I wanted to get a little bit more amplification out of it because when I did my original readings, my measurements, I was able to get 7 volts on the output. Alright? And that's on test point 4 there. I was able to get 7 volts, and granted, not a whole lot of amplification in the first 2 stages, so I don't know why that resistor being only half the value of that one makes that big of a difference, because that's well more than any power of 2 other than like half, double, inverted, you know. It just doesn't make sense to me why I get so much. Maybe I did measure something wrong, right? So I'm sitting here, I'm second guessing myself. I'm looking at it, and let me see if I can get this thing to do what it was doing. I decided to measure it again. And I apologize for how hard that screen is to read. Let me see if I can't get this in there a little bit better. That's about as focused as it's going to get. Now, I'm going to turn my volts per division, and you can see, yes, I do have a little bit of rounding on the tops, and it's pretty sharp on the bottoms. It is what it is. I can't really do much about that without decreasing my amplification. I am right on the hairy edge of overdriving these transistors. Okay? So why am I only getting 2.45 volts output? We are looking at channel 2, and channel 2 is the green one, not that you could see because I'm zoomed in, but channel 2 is the output. If I bring in channel 1 and take channel 2 away, and notice the scale is different, so let me, is it the bottom? Nope, that's the top one. So channel 1 input should be 260 some odd millivolts. Let me or close to it. Currently 273.5. Alright, so that's my input, is 273.5. My output, much higher, at 2.45, if I recall correctly. Somewhere in the neighborhood. And I'm sitting here, I'm thinking to myself, you know, I measured it before. I know I measured it. I know I measured it correctly. I double-checked everything. I was getting 7 volts. Okay, well, let me go back to the drawing board, right? And so I did a little trick. I knew I had values that were pretty close to what I needed, so I took, let's say I needed a 50k ohm. I would grab, well, actually, if I needed 50, I would grab a 100k ohm because the middle of its range is 50. And I would just take one of these little doodads and put it on the board in just such a way. And this is back when I had all of my components spread out a little bit more, so I could do that. And I'd sit here and I'd adjust it, and I'd be looking at those waveforms over there until I got it just right. And doing that, I was able to get exactly the resistance I needed to get exactly the result I wanted. So I'd take my multimeter and I would measure that resistance of the potentiometer. And I would put that resistor, or the closest standard value that I have, in that spot. And I got almost identical, the same voltages, so I was happy. And yet the highest voltage I could get out of it was about what I'm getting right now, 2.45, somewhere in that neighborhood. Now, mind you, for input of a microphone to a cell phone, that is more than enough. If I were doing a clean sine wave input at that voltage, it would overdrive the input of the smartphone. However, using a microphone as input, it has a considerably smaller voltage output, the microphone does, compared to that function generator I've got up there. So it's reasonable to expect that I can use the microphone with this circuit. My output will not be the 2.5 volts or whatever, so I will not be overdriving the smartphone's input. I might overdrive the microphone, but the smartphone will be safe. And that's what I'm worried about. I don't want to break my phone, okay? All of this stuff, little cheapy, microphone or whatever, I could care less about that. That's easy to replace. My smartphone, not so much. So I'm sitting here putting in new resistors and everything, and then I decide, and this is when everything's still spread out, and I decide then to compress it all up, make it kind of tight, and I can make it tighter still if I really wanted to. I could move it over about 3 more spaces easily. And if I got really creative, I might even move some down here and, back and forth. Point being that my original idea of fitting it on this breadboard is definitely doable. So I'm compressing everything, and then I look back up there, and as I'm doing that, I notice something. My bottoms are flatted again, which is a clear sign that I'm overdriving the transistor. I'm slamming it shut. In fact, my bias is off now. And I'm like, well, why would that happen? Because when I was looking at it a minute ago, it was fine. Well, let me tell you what happened. In order to plug it into the cell phone, I'm using one of these adapters. It takes a TRRS that goes into the cell phone and turns it into twin TRS to go into your headphone and your microphone, which is fantastic when you've got the cheapy headphones like I do, okay, because these were another pair that somebody threw in the trash. I guess these are ones that the class gave me because they were so cheap. They let me keep them. The other pair I've got, somebody threw in the trash. But anyway, you see what we got here. These are made for the older style desktop PC inputs that had separate microphone and headphone instead of what everybody's using today. Now, that's good and well. This just saves me from having to figure out the pin out of my phone, because there's actually a couple of different standards, and it appears that when I try either of those standards, it doesn't work. So people who made these things know something I don't. But when I take the headphone jack, and this is by the way, let me move that out of the way. What we have here, okay, is just so that I could move my phone a little further away. That's my kid in the background. So when I take this, see if I can focus on it. There we go, because I forgot I've got manual focus on this one turned on. And you can still see, I know it's fuzzy, but you can still see. When I plug this into the headphone jack, there's no change in that output over there. When I plug it into the microphone jack, it attenuates it. Alright? And now I've got 3 of these things. And I've tried all 3, and all 3 are done the same way. So it definitely is a deliberate design characteristic. Why would they do that? And that's what I don't understand. If I had a line output going to a microphone jack, yes, I would want that attenuated. But if I've got a microphone input going into a line jack, which of course, smartphone's not going to have a line jack, it's going to have a microphone jack. But if I've got a microphone input going to a line jack, I would not want that attenuated. If anything, I would want it amplified. That's why I'm making an amplifier. Derp. So why are we attenuating? I don't know. But now that I know that, I figured out why my sine wave is bottoming out. And now that I know that, I'm going to redesign this. I'm going to figure out the pin out, and I'm going to do it without this. Because here's the thing. I can only get my rail voltage a little bit less than my rail... can't talk today. A little bit less than my rail voltage as output. So if I've got 9 volts here, the highest output I'm going to see out of this thing is about 8.5. And come to find out, that's about what I'm getting. But if I attenuate that, the highest output I can get is 2.5. I would much rather have unattenuated output that I control anywhere between 2.5 and 9 volts, rather than the max I can get is 2.5, and if I try to go any higher, it bottoms out and flattens out and distorts the audio. I don't want that. So I'm going to redesign this yet again, not to use the little adapter that I've got there. Also, you people can hear me. But, yeah, I wanted to share, and I am making progress with this thing. And once I get it hammered in exactly the way I want it to be, I'm going to go ahead and solder all of that onto a perf board, and that's going to become my microphone amplifier, and then I'm going to build it again and turn it into my amplifier for my ham radio setup. So I'm going to make 2 of these things, one for my phones so I can do the videos, and one for my ham radio. So stay tuned, and I'll keep you guys informed. Thanks for watching.